All right, let's take a quick look at synthetic division. Now, we did polynomial division a minute ago, and it's not awful, but you might have been sitting there going, oh, can there please be an easier way? Well, the answer is sometimes. Okay. If all you're doing is dividing by x minus a value, okay, then you can use a shortcut called synthetic division. Okay, so again, if I had like x squared or anything in here, this is going to fly out the window. It's not going to work. But just a regular x minus something, then we have a shortcut. So what we do is we take all of the coefficients of our polynomial, including, you see we have x to the fifth, fourth, third, second, first. We should also have a 0 here for that missing term there. So we've got 2, negative 16, 36, negative 10, negative 24, and 0. And we're going to divide by this root here. Now, if x minus 4 is my factor, then my root would be positive 4. Okay, so don't forget to switch that sign. That does make a difference. And after I divide by x minus 4, I should have 1 degree less, which is why I've got this extra space right here. This extra space is going to be my remainder. So we drop down the first one, and we multiply these. And then we add. It's a little confusing because we were subtracting earlier, but multiply again. Add. Multiply. Add. Multiply. Add. All right, so we've divided this all out. So what does this mean? Okay, well, remember, these all had coefficients next to them. And all those coefficients are going to get reduced by 1 when we're dividing by x. So this is our constant term. This is x to the first, x to the second, x to the third, x to the fourth, which is just 1 down from what we had before. This was x to the fifth, x to the fourth, x to the third, x squared, x, and our constant term. Okay, so it's just 1 less power of x on all these. So our solution is 2x to the fourth minus 8x to the third plus 4x squared plus 6x. Okay, we don't need to say plus 0 here. And what's our remainder? Well, our remainder is 0. If we had something here, we have to write plus 0 over x minus 4, because that's the thing that we were dividing by. But since we don't have anything, we can go ahead and take that off. But this is going to be our solution here. Now, something that's very useful about this, there's something called the polynomial remainder theorem. And basically what the polynomial remainder theorem says is that when we do this division by this root, and we get this remainder, that remainder is going to be the same thing as if I actually plugged 4 into here. Now, I know this seems complicated, but it would actually be really hard for me to plug 4 in here, 4 in here, 4 in here, 4 in here, 4 in here without a calculator. And even for a calculator, it's going to take more effort doing it this way than it is doing it this way. So if you do synthetic division by 4, it's just like you stuck 4 in there. But one of the results of this is if I'm dividing by 4 and I get a remainder of 0, that means 4 is a 0. It's a root. Okay. So in this case, 4 would be a root. Let's do synthetic division one more time on this one. Let's do x minus 8, just to see what happens with other values. Okay. So let me see if I can use a darker marker here. So let's do 8. So we get 2, 16. We add, we get 0, 0 again, 36. We get 36 times 8, which is 288, 278 times 8, 2,224. So we get 2,200 times 8. We get 17,792. And this would be the value if I try to stick 8 in here. Is it a root? Is it a 0? No, it's not, because my remainder didn't wind up being 0. All right, let's try a nasty one that's kind of got some complex stuff in there. So I've got, for my coefficients, I've got 4, negative 8i, 6, 5 minus 5i. I know this doesn't feel like a number, but remember, this is a complex number, even though it looks like it's 2 terms. And we're going to divide by I. Okay, or that's going to be the root that we're going to check here. So we got 4i, so this is negative 4i. Don't forget, what's I times I? It's negative 1. So this is going to wind up being negative 4 times negative 1, so that's 4, 10, 10i. So this winds up being 5 plus 5i. So our final polynomial looks like this. 4x squared minus 4ix plus 10 plus 5 plus 5i divided by x minus I. So this is me kind of rewriting this. And it may seem weird that we feel the need to rewrite it like this, but a lot of times this rewriting will wind up simplifying things a lot. So that's why we wind up doing that. So that's synthetic division. Again, you can't use that all the time, but you can use it whenever you just have this one linear term where it's like x minus something or x plus something. So there you go.